Okay, so third time's the charm, right? This is the third time I'm recording this video. We'll see how it works out. This is going to be over doing domain and range from a different sort of notation. So, first of all, notations. You know that as far as function notations, there's two different ways to write a linear equation. I can do y is equal to mx plus b, or I can do f of x is equal to mx plus b. What's the difference? Y equals mx plus b is just an equation. Okay, f of x equals mx plus b tells me that this equation actually is a function. Hence, function notation, f of x, function of x. Okay, real easy, right? So what about doing domain and range with a different notation? Domain and range. Okay, so the notation we are used to should be this. I have domain, and I can represent this, let's say, from negative infinity to positive infinity, right? Okay, use parentheses on both sides because we can never really get to negative infinity, and we can never get to positive infinity. There is another part of this notation, and it's the square brackets. We use it when x actually does touch certain points, like from 0 to 5. Okay, so x actually can be 0 and it can be 5. And we can do the same thing for range. Okay, so we have range, can also go from negative infinity to positive infinity. Parentheses, because the y value can never actually be negative infinity or positive infinity. Or we could have a range of something like negative 10 to positive 10. And y is able to be equal to both of these. So we use square brackets. Alright, so new notation. And this notation you need to know because it is more exact, it's more precise, and we are going to be using it more often from now on. And I will call this function set notation. Okay, function set notation. And we're still talking about domain and range. So the domain can be written something like this. The set of x such that negative infinity is less than x is less than positive infinity in set. This is set notation. It's very specific. Okay, set being these two curly brackets on the end, and it's the set of x. And then this little vertical line right here means such that. And then I tell what x is in between, right? It's in between negative infinity and positive infinity. Real simple. Now, why do I want to use this? Because I say specifically where it is. It's not, and I say specifically what I'm talking about with x. This can also allow me to do other things, such as say that the domain is the set of x such that x is, okay, use this little e. So x is, and I can say that x is I. Okay, and x is I with x is greater than 0. So what the heck does that mean? Specifically, this means that I am dealing with x. Okay, it is domain, so that makes sense. This part right here means that x is an integer. Okay, has to be a whole number. If it's not a whole number, it's not part of the domain. Whereas before, if we were using the parenthesis in the bracket type, you had to label each individual number if you were using whole numbers. Okay, and had to keep on going, keep writing until your hand got tired. With this new way, this new function set notation, you no longer have to do that. I can just say, hey, they're all integers, big deal, and just make them all bigger than 0. Okay, simple. All right, and I can do the same thing with range. Just replace the D with an R and replace the X with a Y. Easy to do. But back to the main things. So I have curly bracket. which tells you that I'm using set notation. I have x, which is the variable that I'm using. I use this vertical bar, okay, which separates what I'm using from the rest of the information. And it's the way you read it is such that. And then I fill in the remainder of my info. Okay, so 0 is less than or equal to x is less than infinity. And I'm done. All right, that's it. See y'all tomorrow.